Utah Salt Flats Racing Association had their annual 2024 World of Speed event on September 9th, 2024, one day before our UTN Private LTE and 5G testing at the same location on the Bonneville Salt Flats. After the event, the USFRA posted on their website that they had experienced some technical difficulties with their timing equipment. While unrelated to the actual racing at the Bonneville Salt Flats, our UEN project could have helped with those technical difficulties a day earlier. Private 5G is an excellent technology for reaching the distances required of these timing systems. The reduced latency that Private 5G brings will help these associations reduce the complex wiring needed for such events.
We're going to be testing the Vicel's 5G radio, which is shown here. It's a 2x2. We're also going to use kind of our old faithful, if you will, the 436Q. And so that's going to be our first round of testing is 4G versus 5G. The 436Q will have carrier aggregation, and the 5G radio runs kind of a completely different platform. So we're here staging. Chris is getting the antenna ready for us. We'll have the tower up soon.
For our testing, we used multiple devices to verify the connectivity of the LTE and 5G radios. I used an erroneous Spectran V6 spectrum analyzer to get a physical view of the spectrum. In this video, we see both LTE and 5G signals overlapping from the two radios. Using a WLANPi and 5G modem, I have been building a tool for analyzing the neighboring cellular networks as well as the private LTE and private 5G networks. At the Salt Flats, I graphed the neighboring networks and Grafana on the WLANPi. We also decided to test the WiFi HALOW 802.11AH and capture the results using the Spectran V6. Visible signal reached about 1 mile before the signal dropped below the noise floor. The noise floor was about neg 87 dB in the 900 MHz range that Wi-Fi HALOW uses in the US. For private LTE and private 5G results, we were able to achieve connectivity at almost 5 miles from the Cow Tower. Using the spectrum analyzer, we were able to distinguish the physical signal down to the noise floor of neg 105 dB in the CBRS band. Cellular technologies using OFDMA are able to stay connected well below the noise floor, and the iPhone we were using for connectivity testing was able to run speed tests up to almost 5 miles well below the noise floor. From our first testing 2 years ago to this test, we learned that the height of the antennas matters a lot. Our first testing we got 2 miles at 15 feet. This testing we were able to achieve 5 miles of greater connectivity in pristine conditions. For racing fans, cellular technologies work great at speed and velocity, but to avoid overlap issues like we had with our LTE and 5G radios at the beginning, ensure proper subframe assignments. Lastly, we need to do more testing with the WiFi HALOW technology.